Assalamualaikum and a very good day to you all. In this video, I would like to share with you the properties of limits. Okay, so the first properties of limit, if the function is a constant c, okay, so like this, okay, so limit c as x approaches a is equals to the constant itself. Okay, so maybe we have an example like that. Okay, so let's say we want to find the limit of 8 as x approaches 2. So the answer is the constant itself, so 8 lah. Okay, so maybe we can have a graph to accompany our example. Okay, so yes, the limit is always the constant itself. Okay, so next, when just now when the function is constant, right? This one when we have the function as x, okay, a variable x that we don't know. Okay, so when x approaches a value of a, so the limit of the function x as x approaches a is the number that approaches, which is a itself. Okay, so one example like that. Okay, so limit x as x approaches 2 is 2. Okay, so this is a diagram, a graph to accompany our example. Okay, so as we can see here, okay, so when x approaches 2, the limit is 2. So whether it's from the right or from the left, it approaches the same value, which is 2. Okay, so let's continue to the third one. Okay, now when the function is in a form of x to the power of n, where n is a positive integer, okay, then it's supposed to be like this lah. So the limit of x to the power of n as x approaches a equals a, the x approaches, the value of that x approaches to a to the power of n. Okay, so this is the example. Okay, limit x cube as x approaches minus 2. So we just substitute the value of a minus 2 inside the function of x cube, and then we get minus 8. Okay, so this is the diagram lah to accompany our example. Okay, now the next one is if c is a constant. Okay, this is not like the first example. Okay, the first property is if the function is a constant. This time it is this in this form, whereby the c is a coefficient of a function like this. Okay, so if c is a constant and we want to find the limit of this kind, limit c fx as x approaches a. Okay, so what we can do with the c is that the c can go in front. That's why you see the c is over here. Okay, we can take out the c. Not take out lah, it's like factorize lah. It's like more or less like a constant, how constant behave in matrices. Okay, we can move them front and back. Okay, so same goes to this one. They share the same property. Okay, example. Okay, this is the example. Okay, so you see 9 here is the constant, right? So we can put 9 outside the limit. That's why you see 9 over here. So how to find this one? We use the previous properties. Just substitute the 10 inside x squared like this, and then just multiply back by 9 to get 900. Okay, next is when we see limit something like this. It's a limit of a multiple function, okay, whereby the first function is the addition or the subtraction of another function, okay, as x approaches a. So what we can do with this is that we can separate them like this. We can find the individual limit for f and g first, then we can add or subtract them later. Okay, so in this case you might think it's like expansion, macam darab to each one of them, but it is not. That's why the name of the video is about the properties. Okay, this is the properties that they have. Okay, it's not that it's not the operation is not limit x approaches a darab fx. No, it's not. Not. It's more. It behave like one, but it's not. It simply means that this property simply means that we want to find the limit of a multiple functions that add to each other or subtract each other inside a big bracket. We can find the limit of individual function, and then we add them or subtract them later. That's all what it means. So let's look example down here. Okay, you see over here, we want to find the limit of x to the power of 5 plus 2x minus 5. So how many functions, different functions we have here? 1, 2, 3. We have limit here, right? So it means that this one, by using this property, okay, it equals the limit of the first function, this one, plus, okay, the limit for the second function minus the limit for the third function. So in this case, we find the individual limit, then we do the operation. So limit, the first one, limit x to the power of 5 as x approaches minus 2 is simply just the substitution for this one. Okay, and then the limit of 2x as x approaches minus 2, same process, minus limit 5 as x approaches minus 5. This is the very first properties we've seen just now. And then we have the individual limit. Afterwards, we perform the operation adding and subtracting. Therefore, we get minus 41. Okay. Now, the next one is like this. If we have, just now the operation between the functions is plus and minus, right? This one, as you notice, the operation here is multiplication. Okay. Now, these properties is not the same with the properties of arithmetic that you've learned before. Okay, so you need to pay attention. Okay, as I said, this one means that we want to find the limit of a multiple functions that add to or subtract to each other. We can also find the limit of each one of them. Then we tambah or tolak them. So the same principle hold for the next the next properties. This one multiply, right? Fx multiply gx, right? This one also the same thing. We can find the limit of fx first, then we find the limit of gx, and then we multiply them. That's why we write something like this. This is not the same as a number we multiply a plus b like this. Okay, this one tambah, sorry, 2a multiply b. Okay, it's not the same as this one. Okay, that's why I said it's not like the previous arithmetic thing that you've learned before in high school. Okay, so because as you can see here, cannot lah this one, because 2a multiply b is simply 2ab. Okay, but in limit, this property hold. Okay, so we can find the limit of fx first, and then the gx. Afterwards, after that, we can multiply the limit, the number that we get lah. Okay, so look at the example like this. Okay, so this one, okay, this one I write lah, this one. The solution is down there. I just hide them in white color. Okay, so as we can see here, we can find the limit of individual function. This is the first function, this is fx, and this is the second function, this is the gx. So by following these properties, we can find the limit x approaching minus 1, x squared minus 5, and then we multiply limit of x plus 1 as x approaches minus 1. Put bracket lah. Okay, I don't want to get confused. Okay, put that. Okay, now fine lah. This one. Okay, just ganti lah. Minus 1 squared is 1. 1 minus 5. Okay. And then this one multiply, right? Okay, and then this minus 1 plus 1. Okay. And then this is minus 4. Multiply. This is 0. Therefore, the answer is 0. Because we multiply minus 4 by 0. Okay. So, next. And the last one lah. Okay, now the first one just now we saw the limit when fx plus gx. Just now the next one is limit fx multiply gx. This time is limit fx divide gx. This one hold the same exact principle as the multiplication one. The one we just did. Okay, if we have a limit of a fraction like this, okay, we can find the limit for the numerator first, and then denominator, and then we can divide them. That is why we get something like this. Okay, don't worry much about this. This is just some need restriction lah. Okay, it doesn't really matter. Don't worry so much. Okay, so again, as I repeat, this one is not the same as multiplying A with 2 over B. Okay, this is not the same. Not A2 divide by AB. Okay, this is not. Okay, this is only this is not true in arithmetic, typical arithmetic. Okay, this kind of thing only applicable in limit. Okay, now, so let's have example. You see this one? This one, right? Okay, easy lah. As we mentioned just now, we agreed just now, we can find the limit of numerator first. So limit x minus 1 as x approaches minus 3. Okay, and then limit of x squared as x approaches minus 3. And then this one minus 3 minus 1 minus 3 squared. Okay, and then put here lah. Okay, minus 4 divide berapa ni? 9. Okay, so therefore minus 4 over 9. Correct. Okay, so yes, I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.